students. This is Anjali, Assistant Professor, Department of CSE, AIML, IARE, Hyderabad. Today's our topic is data visualization using scatter plot. In previous class, we have seen about that random forest. In random forest, generally we have used supervised algorithm, supervised algorithm where we have trained our model and then we will give the data for the classification and regression. So on that basis again we have seen that how to assemble our data by using the bagging and boosting. But today we are seeing that data visualization using the scatter plot. Our topics are data visualization, what is scatter plot, history of data visualization, scatter plot application and uses, and challenges with using scatter plot. So first we will see what is data visualization. Actually, data visualization is a graphical representation of quantitative information and data by using visual elements like graph, charts, and maps. Actually, data visualization means what? It's like a graphical representation where we are using only visual elements. Which visual elements like graph, charts, maps, images, pictures. By using these things, we can visualize our data. And this data visualization generally convert your large and small data sets into the visuals. That means it is easy to understand and process for the humans. And data visualization tools provide some accessible ways for understanding the outliers, patterns, and trends in the data. Definitely, when we are collecting the different types of data, at that time of that data will contain some patterns, some of the trends, and again some of the outliers are also. So outliers means most of the time that is the unwanted data we have to remove. So in the world of the big data, data visualization tools and the technologies are required to analyze the vast amount of information. Whatever you have the information, whatever you have collected the information, all the data we have to visualize. All the data we will visualize by using the data visualization tools. And nowadays there are so many technologies also for the visualization of the data. But data visualization mostly commonly we used in the everyday life, but they always appear in the form of graphs and charts. The combination of multiple visualizations and bit of information are still referred to as infographics. Generally, these multiple visualization and some of the bit of information, they are represented in the form of graphs, in the form of charts. That's why we will say these charts are these visualization are the infographics, and the data visualization are used for discovering the unknown facts and the trends. Definitely, when you are collecting the data, when you have a data, so at that time you will visualize data, you will discover your unknown facts and the trends, and you can see your visualization in the form of like line charts, in the form of scatter chart, or you can display the different you can display the data in the form of different charts like bar and column charts are very useful for the observing relationships and the making comparison. Then pie chart is very good way to show the parts of a whole. Then and maps are the best way for sharing the geographical data visually. And nowadays data visualization tools go beyond the charts and the graphs used in the Microsoft Excel spreadsheet, which displays the data in more sophisticated ways such as dials and gauges, geographic maps, heat maps, pie chart, and fever chart. Generally, Microsoft Excel spreadsheet containing so many charts like light chart, pie chart, then scatter, bubble chart. Every chart is very important here, and every chart will show the some of the geographic maps and some of the fever chart also. Every chart will represent your data, and because of that it is very easy for the human being to understand the data. Now, what is meant by scatter plot? The scatter plot is a chart type that is normally used to observe and visually display the relationship between the variables. By using the scatter plot, you can observe your data, you can display the relationship between the variables. The values of the variable are represented by the dots, and the positioning of the dots on the vertical and horizontal axis will inform the value of the respective data points. Hence, the scatter plot make use of Cartesian coordinates to display the values of the variable in the data set. So, for example, we can say there are two axes. This is your x-axis and this is your y-axis. This is your origin. So, whenever you want to plot your scatter plot, you will observe the values from the x-axis and you will observe from the value y-axis. So, on that basis, you can positioning your data. You can show over your data. So, scatter plots are also known as the scattergrams, scatter graphs, or the scatter chart also. And the most common use of scatter plot is to display the relationship between two variables and observe the nature of such a relationship. So here the scatter plot mostly it will compare the relation between the two variables, it will observe the relationship between the two variables, and this relationship observed can be either positive or the negative, non-linear or linear, and sometimes it will be strong or weak also. So this is your model. These are your observation. So on this basis you can see these are your dots. So these dots we got on the basis of the x-axis and the y-axis. Now, history of the data visualization. The concept of using picture was launched in the 17th century to understand the data from the maps and the graphs. And then in the early 1800s, it was reinvented to the pie chart. Actually, most of the time picture generally was launched in the 17th century first time, and so for understanding purpose we have used the maps and the graphs, and after that again that same data reinvented by using the pie chart. And several decades later, one of the most advanced example of the statistical graphics occurred when the Charles Minard mapped Napoleon's invasion of Russia. So the map represents the size of army and the path Napoleon's retreat from the Moscow, and the information tied to temperature and time scales for more in-depth understanding of the event. So here you can see that the 2nd century, 17th century, 17th century, and your visualization is started from the 17th century, because in 17th century first time picture was launched, and on that basis before that understanding we have formed the map and graphs. Then the computers made it possible to process a large amount of data and it lightening fast speed. But nowadays data visualization become fast, involving blend and science that certain to change the corporate landscape over the next few years. Even nowadays so many tools are there, so many technologies are there for data visualization. So nowadays it is very easy to visualize your data by using the graphs, by using the charts. So you can visualize data very easily. Now we will see the scatter plot applications and the uses. First one is demonstration of the relationship between two variables. The most common use of scatter plot is to display the relationship between two variables and observe the nature of the relationship. The scatter plot mostly is used for displaying the relationships and the relationship between the two variables, and it will observe the nature of the relationship. That means what kind of the relationships are between the two variables, and these relationships observed can be either be positive or negative. Sometimes it can be linear or non-linear, and sometimes that relation can be strong or weak also. So data points or dots which appear on the scatter plot represent the individual values of each of those data points and also allow pattern identification when looking at the data holistically. So whatever data points you have got, you will appear in the scatter plot, and that scatter plot will represent some individual values for the particular data points, and it will contain some of the pattern, one of the pattern for identification. So second one is the identification of relational relationship. Another common use of scatter plot is that they enable the identification of correlational relationship. Here it will your scatter plot will help to identify the correlational relationship, and the scatter plots tend to have independent variable on the horizontal axis and a dependent variable on the vertical axis. If you are using the scatter plot, so at that time you have two types of variable, one of the independent variable and another one is the dependent variable. So if you have an independent variable, so it will represent on the horizontal axis, and if they and variables are the independent, then it will show on the vertical axis, and it allows the observer to know or get an idea of what the possible vertical value may be, or provided there is information on the horizontal value. Now third one is identification of data patterns. Now how we will identify our data pattern? The data pattern identification is also possible with the scatter plot, and the data points can be grouped together based on how close their values are, and these are also makes it easy to identify any outlier point when there are data gaps. Definitely, if we got the one of the data pattern in by using the scatter plot, so it will create one of the pattern, and we can identify that is there any outlier point or not. If there is outlier, that means we can avoid or we can remove that one. But by using the data pattern identification, we can group together our points, and we can see which points are close with each other. And seeing as the scatter plot aid in the identification of correlations between variables, the nature of the correlations can also be estimated based on the specific confidence level. You can identify the nature of the correlations by using the specific confidence level, and you know that when we are talking about the confidence level, then it will search for the 67%, 95% or 99% also. So here we will see about the confidence level, and the positive correlation depicts a rise. It is seen on the diagram as data point slope upwards from the lower left corner of the chart towards the upper right corner. And the negative correlation depicts a fall, and this is seen on the chart as data point slope downwards from the upper left corner of the chart towards the lower right. Data that is neither positively nor negatively correlated is considered uncorrelated. That means we can say it is the null data. Also, through the use of the line of best fit or trend line scatter plot to help identify the trends. Following the best fit framework, an equation can be derived in conjunction with the relationship that exists between the variables. Linear regression is part of the best fit framework and is used for linear correlation. Now we will see how to create scatter plot. we have a raw data. This is month column, series 1 and series 2. So there are some values. There are month names, series 1 values and series 2 values. So on this basis, we will find out our scatter plot. The scatter plot diagram for the data above is seen below. See, so third, series 1 and series 2. Series 1, 5, 10, 40. These are series 1 and series 2. On that basis, you have drawn the data. You have plotted the scatter plot. This is your scatter plot. And to create the scatter plot diagram, similar to the one above, following steps can be taken in the Excel. First, all the data should be recorded in Excel as seen image above with the title actually raw data. That means like raw data, and you can show your data on the y-axis and on x-axis. Then secondly, the data range should be selected. That is series 1 and series 2 in our example. See, there is a data range. That means series 1 range is a 10 to 40 and series 2 range is a 5 to 35. So we can decide, we can increase our range also. So on that basis, we will get the sum of the points and we will plot our scatter plot. And then next on the insert tab, Excel ribbon, click onto the scatter plot and symbol as shown as seen below. See, this is your Excel sheet. In Excel sheet, you can map. You have to click here on the chart menu. After clicking the chart menu, you have to select your scatter plot, and on that basis, on the basis of the data, you have to plot your scatter plot. After clicking the charts, you will get these menus: scatter, bubble, then another charts are there. Just you have to click on the scatter. Then the chart will be generated and heading and visual representation can be adjusted in accordance with the preference. And here scatter representing, use this chart type for comparing at least two set of the values or pair of the data. Then you have to show the relationship between the sets of the values. And when we will use the scatter plot, when the data represent the separate measurements, so at that time we can use the scatter plot. Now, which challenges are there when you are using the scatter plot? First, two common issues have been identified with the use of scatter plot. First one is the overplotting and another one is a interpretation of the causation as a correlation. First, overplotting. Generally, overplotting occurs when there are too many data points to plot, which results in the overlapping of the different data points. When the overplotting will occur? Actually, when you have a number of data points and you have to plot those points, and after plotting those points, we got the result like a overlapping of the different data points. So at that time your overplotting can occur. It can make the relationship identification between the variable challenging. So concerning correlation, it is important to remember that correlation does not mean that changes observed in one variable are responsible for the changes observed in another variable. That means correlation is representing that if you have got the sum of the changes in one variable and those changes are not responsible for the changes observed in another variables, that means both variables are not dependent on each other. Correlation should not be interpreted as the causation. Then causation implies that an event occurring will have an impact on an outcome. So these are the challenges with using the scatter plot. So main issues occur, like first one overplotting and another one is a interpretation. If overplotting, when overplotting will occur, if you have a too many points for the plotting, so at that time your overlapping can be occur. So here interpretation also is another issue. You have to interpret your values, but you should not consider that if one of the variable is observing some changes and same changes will be observed by another variable also. So this correlation should not be interpreted as the causation, and that's why causation maybe implies that event occurring will have an impact on an outcome. Then uses of the scatter plot. Use a scatter plot to compare two key variables in your data to determine their relationship. If you want to determine the relationship between the variables, so at that time you can use the scatter plot for comparing purpose. For instance, you can use this chart to track the relationship between click-through rate and conversion metrics in digital marketing. Even you can use this chart for tracking the relationship between the click-through rate and conversion metrics. Then in this scenario, you would want to know whether the growth of the click-through rate impacts conversion value. Here you have to check that click-through rate is impacting on the conversion values or not. Essentially, you can use the scatter plot example to determine relationship or associations between the key data points. You have to determine the relationship or you have to determine the associations between the data points. The actual analysis comes in when you discern the type of relationship existing between key metrics you are tracking closely. And even you can use the scatter plot to uncover hidden cause and effect relationships between the two variables in your data. And below are the some scenarios you can apply the scatter plot example to get maximum from your raw data. There are pairs of the variable in data. Then dependent variable have multiple values for each figure associated with the independent variable. That means there are some dependent variable and independent variable also, but dependent variable have multiple values where we can figure out with the independent variable, and there are sign of the relationship between the two variables in the data. Now first there is one of the example. Imagine you want to analyze the height, weight, age of the school going children in your neighborhood, and let's assume the data below is what you have collected, and you have collected the age of the children, then height of the children, weight in the kg and weight legend. So you have collected all those data, and now you have to visualize this data. To visualize the data below with chart expose scatter plot, and you have to follow these steps. First, you have to open your Google Sheets desktop application. Here we are using the chart expose scatter plot, and for this you have to follow these steps. First step, open your Google Sheet desktop application, then open the worksheet and click add-ons menu button. Then once the chart expo based data visualization tool drop down menu shows, the click open button. So these 3 steps you have to follow every time when you have to draw the chart expose scatter plot. So there is a chart export data visualization tool is available, and now after clicking this, after selecting the chart expo, you have to click the create new chart button, and after that you will see 6 main categories of the spreadsheet charts, and after that click the PPC chart tab to access the scatter plot. See, there is a scatter plot. You have to click on the scatter plot and copy the data from above table and paste in the sheet. Whatever you have collected the data, that data you have to paste, you have to bring into the Excel sheet. After that, fill in your metrics and dimensions. In our example, we have two metrics. One is age and another one is a height. The dimensional variable to fill in is weight in the kg and weight in the legend. See, there are weight in the kg and weight in legend. So these are very important data. This is very important data for us, and the resulting chart should look like one below. See, this is your resulting scatter plot. So there is a positive correlation between height and age of the children. In other words, the height rises with the age of the children. Moreover, few are below average and few above the average line. Now there are different types of the scatter plot. The scatter chart come in different variants based on the some factors. First factor is a correlation and another one is a slope type. Scatter charts are divided into three types based on the correlation. First is strong correlation, another one is a moderate correlation, and third one is a no correlation. These are your dependent variable and these are your independent variable. This is your strong correlation. And in this strong correlation scatter plot, the data is plotted in dots, keeping the independent and dependent variable in the y and x axis respectively. As shown above, all the markers or data dots are closely arranged linearly, so trend line can be plotted. And this means that there is a strong correlation between the key data point. Therefore, diagram above the qualifies to be called scatter diagram with the high degree of correlation. Then second one is scatter chart with the moderate correlation. See, again these are your dependent variable, independent variable. This is your x-axis and this is your y-axis. So on this basis, your points are plotted in the plot. So in the diagram, the data points are arranged in somewhat closer to each other. And in this chart, your charts are closely arranged. Your dots are closely arranged in the strong correlation. But in moderate correlation, these data points are arranged somewhat closer to each other. They are not fully linear, which means you cannot draw a straight line through them. But in strong correlation, we can draw the straight line through them. As you observe closely, you will notice that there is a less significant relationship between the variable. But in the strong correlation, it is showing that the strong relation between the two variables or two or more three variables. This chart is also known as the scatter diagram with the low degree of correlation. And strong correlation, it was showing the high degree of correlation. Now scatter chart with no correlation. Again, this is your y-axis, this is your x-axis, and independent and dependent variable. So here you can see your dots are very far away from each other. So in this scatter plot example, data points are scattered all over the place. Besides, it's not easy to decode the relationship between the data point. We cannot identify the relationship between the 2 points also. This data visualization design qualifies to be called scatter diagram with no degree of correlation. That means there are the strong correlation, moderate correlation, and the next one no correlation. So in no correlation, it will show the no degree of correlation. And now there are the scatter plot real world application displaying the hidden relationship between two variables. Scatter charts are widely used to display the relationship between the two variables. The relationships you can uncover using the visualization design are categorized positive or negative, non-linear or linear, and strong or weak. The dots which appear on the scatter plot represent the individual values of each of the critical data points. More so, they allow you to extract the trend insight from data faster. Identification of correlational relationship. How you will identify the correlational relationship? Just you can use the insightful chart to uncover hidden correlational relationship which are existing in your raw business data. Then second one, interpreting the scatter plot example is incredibly easy. The key to interpret this chart is always to remember that independent variable sit on horizontal axis and the dependent variable are always sit on the vertical axis, that means y axis, in a Cartesian plane. Now you have to identify your data pattern. Use for identifying your data pattern, you have to use scatter plot to identify the general trend of your critical variable in your raw data. If in your data there are critical variable, so at that time you can use your scatter plot. Data points in this chart are grouped based on how close these values are, and which makes it easier to identify the outlier. You don't want to base your business decisions on outlier because they are outright misleading. Interestingly, the nature of correlations can also be estimated based on specified confidence level. The positive correlation depicts an uptrend. Essentially, in a scatter plot with positive correlation, data points slope upwards from the lower left corner of the chart towards the upper right, and the negative correlation depicts a downtrend. Positive correlation depicts an uptrend and the negative correlation depicts downtrend. The key data point slope downward from upper left corner of the chart towards the lower right. So data points that neither positively nor negatively correlated are considered uncorrelated, which is called the null. Then there are some pros and cons of using a scatter plot. The scatter charts are incredibly crucial, especially if your goal is to display the correlational insights. You can use this chart for displaying the correlation between the critical metrics in your data. If you have collected the critical data, so at that time you can use the scatter plot. You can use for displaying your correlational correlational insights. Then data visualization experts consider scatter plot an apt visualization designed to show the non-linear relationship in data. For showing the non-linear relationship between the data, we can use the scatter plot. Again, scatter plot are amazingly easy to read even for non-technical audiences. The range of flow of the data in scatter plot example readily visible, and this means you can point out maximum and minimum points in your data at a snap of the fingers. Then many people think that scatter plot and the line graph are similar, but when you will compare the scatter plot and the line graph, you can find out both charts are totally different. Both charts have charts performing differently tasks. So there are some weaknesses also which are associated with the scatter plot chart. You have to keep in mind. First, you cannot use this chart to display the correlation of more than two key variables. If you have more than two key variables, so at that time you cannot use the scatter plot. Only data you numerically compare is visualized using the scatter plot. Although scatter plot uncovers hidden relationships in the data, avoid assuming a particular variable is causal agent of the problem you are trying to solve. These are all about the data visualization using the scatter plot. These are your references, so you can go through this.
Like, share and subscribe. Hit the bell icon for more updates.